All right, so we're back here for part 2, and we're at the bottom of the first page of notes. And so we have directions: convert the following repeating decimals to fractions. Now this is a topic that actually is a little bit beyond Algebra 1. But what I want to show you is really prove to you that a repeating decimal is rational. Rational means I can write it as a fraction. So if I look at 0.33333, what I'm going to do is I'm going to use the letter, I'm going to use a variable, I'll call it n. Okay, n just represents a number. N is 0.3 repeating. Now, one thing I'm allowed to do when I solve equations is I can multiply an equation by a different value. So let's say I multiply both sides here by 10. I'm going to multiply the left side by 10, and I'm going to multiply the right side by 10. So what happens is we get 10n. Actually, I'm going to rewrite the first thing. And then here's what I get. This is 10n equals, when you multiply by 10, what happens is you shift the decimal over one place to the right. So what would happen is that this times 10 becomes 3.3. And I know that this is a 3 because this means repetition. So this is 0.33333. It keeps going. So if I write it like this by multiplying by 10, that's 3.3333, which I'll write as 3.3 repeating. Now, here's the reason why I'm going to do this. I am allowed to actually subtract the sides of an equation. So if I subtract here, this is 1n minus 10n, I get negative 9n. And if I do 0.3 repeating minus 3.3 repeating, this is 0.33333. This is 0.33333. So what would happen is that these will cancel to 0. And what I'm left with is 0 minus 3, which is negative 3. So what I've been able to do here is to get rid of the repetition part, the decimal part. Now I can solve this equation. I would divide by negative 9. And so what I get here is positive 1n, or just n, equals negative divided by negative. That reduces to 1 over 3. And just to show you, 1 divided by 3 as a decimal is 0.3. Now this puts a dot here, so that's just 0.3 repeating. Okay? So this fraction is equivalent to this repeating decimal. Let's say I do it here for 0.27 repeating, 0.27. So that would be 0.27272727. So I'm going to say let n equal 0.27 repeating. Now this time I need to move the decimal 2 places. So what I would do is multiply this by 100 on both sides. So if I did that, I would get 100n equals, this would shift twice. So I would get 27, but remember it's repeating, so 27.272727. But what I have, since the decimals here are the same, now I can solve by subtracting on both sides. This is 1n minus 100n, which is negative 99n, equals, the repetition will disappear. That will cancel to 0, and 0 minus 27 is negative 27. And so our last move here is divide by negative 99. A negative divided by a negative is positive, but we can also divide each of these numbers by 9 to reduce. And what we get is 3 over 11. Let me test that out. 3 divided by 11. Change that to a decimal. Look at that, 0.2727. Okay, and for the last one here, go ahead and pause it and see if you can figure it out. All right, well, n equals 3.15. I only care about the part that's the decimal, the repetition part. So I'm going to multiply again to move 2 places. I'm going to multiply by 100 on the left side and the right side. So this would become 315 point. The 15 repeats. And now if I subtract, 1 minus 100 is negative 99n. 3 minus 315 is negative 312. 0.15 repeating minus 0.15 repeating is 0. And then the last move here, divide by negative 99. And if you reduce this, we can divide each of these by 3. N equals, we get 104 over 33. So I divided here by 3. Is that correct? Well, 104 divided by 33 as a decimal is 3.15 repeating. Okay, so that's kind of cool. Now, last thing we're going to do here is to flip it over. And we're going to talk about exponents, do a review of exponents, square roots. So if I have 2 raised to the third, and the way I read this is 2 raised to the third power, or when the exponent is a 3, we would say 2 cubed. The 2 is what we call the base. And then the 3, the small number, is what we call the exponent or the power, What the exponent tells you is the number of times the base multiplies itself. So 2 raised to the third, and we say raised because it goes up a little bit, this number. It's smaller and it goes up. That means 2 times 2 times 2. So we take the 2, we take the base, and we multiply it by itself 3 times. Now you could say that's equal to 8, but when we write it out like this, we say that it is expanded. We made it longer to expand. So, number 5, expand negative 3 raised to the fourth and evaluate. Expand means to write it out. So what we're doing is we're taking the base, negative 3, and multiplying it by itself 4 times. The exponent tells you the number of times. Now, there's a couple ways to do this. You could do negative 3 times negative 3, take these two, and that makes positive 9. And then negative 3 times negative 3 again makes 9. And this is 9 times 9, which is 81. So they're asking us to do 2 things. They said expand, that's this part right here. Evaluate means find the value. The value overall is 81. Okay, how about negative 10 raised to the third? That means we take the base, negative 10, and multiply it by itself 3 times. We can do negative 10 times negative 10. Negative times negative is positive. 10 times 10 is 100. Now, 100 times negative 10, a positive times a negative is a negative, and that's negative 1,000 right there. Now, this even works with variables. I'm going to come back up here. If I wrote x raised to the 5th, where I don't know what this number is, it doesn't matter. I can still expand and multiply x by itself 5 times. Okay, so 5 raised to the 2nd, we would also say there's a shortcut to that. We say it's squared. That's 5 times 5, which is 25. Now the reverse of that is what we call the square root. This check mark looking thing here is called a square root. Now you're thinking, what number times itself gives me 25? So the square root of 25 is 5. So if I say 3 squared, 3 times 3 is 9, then we know the square root of 9 is 3. 7 squared is 49, so the square root of 49 gives us 7. So a square root reverses the process of raising it to the second power of squaring. Okay, so squares and square roots, they undo each other. If I say, I'll do one more here, 10 squared equals 100, 10 times 10. The square root of 100 is 10. That's it. So the last thing here, evaluate the following expressions. Now this is the opposite of the square root of 144. So can you think of two numbers that multiply each other that are the same, that get you 144? Well, that's actually 12 times 12. So our answer, because of this being negative here, our answer is the opposite of 12. So we are evaluating, we're finding the value. The value is negative 12. If you take the square root of a fraction, we can take the square root of the numerator, 81, and we can take the square root of the denominator, 49. The top of the fraction is a numerator. The bottom is a denominator. Lots of vocabulary here. Well, what number times itself gives you 81? So that's 9. What number times itself gives you 49? That's 7 times 7. The square root of 49 is 7. Our answer is 9 over 7. And the very last one here, the square root of 0.16. If we ignored the 0.16 and just thought square root of 16, what number times itself gives you 16? Well, wait a minute, that's 4. So what's going to happen here, you could think of this as 16 over 100. That's what this decimal is, 16 hundredths. So let me write it like that. Now I can write the square root of the numerator and the denominator. What times itself is 16? Well, that's 4 times 4. So the square root of 16 is 4. What times itself is 100? That's 10 times 10. Square root of 100 is 10. Now the last move here, when you have a fraction, don't forget you have to reduce. We can divide each of these by 2. So we're going to simplify, and we get 4 divided by 2 is 2. 10 divided by 2 is 5. That's a good answer. Or 4/10, you can write it, that's 0.4. And that is the end of the notes.